All right, so here are the similar questions for your twin for 7.1 through 7.4. So the similar question here is, sorry about the interruption there, 3 times 2 raised to the x minus 2 plus 3. This is a shift, not left, right 2, and that's an up 3. So you're going to have to go over there and compare and contrast that with this equation, okay? I'm going to shift right 2, and I'm going to draw it in, and I'm going to shift up 3. Now the way I would have taught you in class is exactly what I'd do here. I would make a table, and this x value, this x equals 2, is the center of my table. And then I would go 1 unit before, and I'd go 1 unit after. And I would plug those numbers in. Plugging in 2 is actually really easy. You plug in a 2, that's a 0. 3 times 1 is 3, add 3 is 6. And the reason you pick these points is because they work out fairly nice. Now, this has a 3, so you're going to get a decimal. But, I mean, you're familiar with the storage feature by now, aren't you? You should be. Take a 1, store it to x, 3, 2, rooftop, x minus 2, add a 3, 4.5. This is gross, so I expect when I plug in a 3, it's going to be quite a bit. 3 you can do by hand if you want. That'd be 3 times 2 is 6, add 9, because this is going to be to the first power now, but, you know, if you don't believe me, take a 3, store it to x, enter, enter. It's a 9. I told you it would be a 9. It was. So, my point is 1, 4.5, about right there. 2, 6, right there, and then 3, 9. Now, this is the definition of exponential growth. And all exponential growths look like that. So that's exactly what that one's doing right there. And it's really taken off at those 3 key points, okay? Domain of any exponential growth function is negative infinity, positive infinity. This one's low y value is ridiculously close to that 3. Never actually gets to be 3. But after that, it just shoots off to infinity. And this is the horizontal asymptote. For my example, which was a plus 3, this is y equals 3. They're not hard. This one, I see the 1/2, so I know it's decay. All decays start high and low. So it's going to grow, it's going to be high when x is negative, and it's going to go on down. Same over here, that's exponential decay. I see a left 3, down 5 is what I see. So again, I draw them. You know, what do I know? What do I know about math, right? The way y'all don't listen to me makes me think you know more than I do, but yet your grades say otherwise. This was where x was negative 3, and that is the center of my table. So something before negative 3 is negative 4, something after negative 3 is negative 2. And again, those 3 things generate the best numbers. That's why we use them. We find kind of the center, and then we plug in. The easy one would be the negative 3. It's still going to be a decimal, though. None of these are going to be nice. None of them. But anyways, take a negative 4, store it to x. 6 parentheses 1 over 4, rooftop to 2, the x plus a 3. And then minus a 5. 19. That's high. That's off the grid, isn't it? Take a negative 3, repeat. I got a 1. That was kind of nice. Take a negative 2, repeat the process. I got negative 3.5. So it's doing what it's supposed to do. It's starting high off the grid. At negative 4, it's legit off the grid. What it is. Negative 3, you're at 1. And at -2, you're at -3.5. And the rest of this is based on realizing its decay. You're going to start up at positive infinity, and you're going to fall, and then you're just going to flatline right on out along that asymptote. And that's how they work, kids. Don't believe me? Graph it in your TI-84. Look at that thing. Domain is still negative infinity to positive infinity. Oh yeah, if you like set builder. All values of x such that x is an element of the real. The range is going to be a low value of -5 up to the high value of infinity. If you like your set builder notation, all values of x such that x is greater than or equal to -5. And the horizontal asymptote again is right here. So y equals -5. That's what it is. It's not that hard. I didn't actually do the set builder up here. I should. All values of x such that x is an element of the real. And all values of y. I don't know why I said x earlier. All values of y such that y is greater than or equal to 3. Ta-da! Last one I'm going to do so I can leave today, because I've been grading your tests all day, and I'm not in the mood to do much else after that. Why won't y'all use a calculator? I don't understand you. Anyways, the average rate of change for this exponential growth function over that interval. So average rate of change is f of b minus f of a over b minus a. Some of you morons are going to try and do this by hand. Don't. You're not me. And heck, I'd screw it up from time to time. Take a 1, store it to x, just type that thing in. Boy, that's got some contrast there. Anyways, f of b is -14. It's got a minus symbol in the equation. Repeat the process with a -3. Again, remember, I'm doing a similar example here. I'm not doing the same one you got. A -2.75, and it's sitting over 2 minus a -1. And you know, if you don't know what some of this stuff is, just push the buttons, kids. You got a -14, and if you don't know what minus a negative is, push minus a negative. It's not going to kill you. Just showing you, even though you shouldn't do things like that, your calculator will figure it out. And that's -11.25 over 3, because 2 minus a -1, which you can't see. There we are. Throw this away. What's that? Wish I could get that contrast right. Let me darken the screen up a little bit. There we go. Anyways, you divide that by 3. You bring up my old work. There it is. Divided by 3. You get -3.75. If you like fractions, hit Math, enter, and you get -15 over 4. It's really up to you. Okay, that's the average rate of change for that exponential growth function over that interval. It was still falling. It wasn't growing. Still on the way down. I guess I'll do 4 since I'm in the mood. So you purchase your first car, and the similar question says you borrow $14,250. It is a 6-year loan at 7.9% interest. And let's leave the compounding the same. Compounded monthly. So there's a formula you're supposed to know. It's called the formula for compound interest. The amount after time passes is the principal times 1 plus r over n to the n t. Memorize it. You are going to borrow $14,250. 1 plus 5.9% as a decimal, 0.059. Compounding monthly, there are 12 months per year. Rooftopped to the NT, 12 times a 6. That's the setup. That's it. In my question, it's a 6-year loan. So I'm just going to push the buttons and see what it generates. Okay. 14250, 1 plus 0.059. Oh, I about screwed up. In my similar problem, it was 79. Looking at too many things at once. Over 12, roof-topped to the 12 times 6, if I don't know, that's 72. $22,855.77. So interest is a killer, isn't it? That's $6,000 in income you have to come up with. When you borrow money, that's the deal. You've got to pay it and more back. Determine your yearly payment. Well, this was for 6 years, right? So take your total and divide it by 6. That's what you pay back every year. $3,809.29. Determine your monthly payment. Well, the last I checked, there were 12 months in a year. So take that quantity and divide it by 12. And there's your monthly payment. $317.44. If you're lucky enough, your parents bought you a car. Most people aren't that lucky. Let's do 5 and then I'll get out of here. 5 is about a certain rumor. It says a certain rumor about you grows exponentially at a rate of 200% every 5 hours. Assume your 2 worst friends currently know the rumor. Similar is 300 every 4. So this is growing. Therefore, I need to be using the formula for exponential growth. I have to modify it a little bit because this talks about every. All right. Now, you're told the principal, 2 of your worst friends know the rumor. So 2 there for the principal. The rate of growth is 300%. 3. 300% is 3 when you express it as a decimal. And we have to play with that. This is going to be t over 4. So after I clean that up, I have 2 times 4 to the t over 4. And don't you be that kid who does 2 times 4. Now it says, convert the model such that the fraction has been moved inside the parentheses. This is turning it into an hourly model. This changes t into periods of 1 hour. So the amount after time passes is 2 times 4. And I'm going to do this in 2 steps for you. I'm going to rewrite t over 4 as 1/4 t. All right? Then I'm going to move that 1/4 inside because I can, because it's a legit move. Now, I feel that the 4th root of 4, don't ask me how I know this, is probably the same thing as the square root of 2. It is. So the amount after time passes is 2 times root 2 t. Now, honest to God, this is where you stop. This is like super extra. But anyways, what you actually do on any standardized test is you take that decimal that your calculator gives you and you put it out 3 to 4 places. All right, I'm going to go 4. A lot of times it's 3, but I'm going to go out 4 because I'm going to be just a little bit extra. There's your model. But again, the root 2 deal, super extra. All right, it says 3, using your model from part 1, because this is before you modified it, determine how long it will take the entire DHS student body, which is 340 kids, to know your worst secret. So this is the amount after time. Oh, and I didn't do a similar, well, it doesn't matter. We're using this new equation. So 340 is equal to 2 times 4 to the t over 4. And this is something that I can do a y1, y2 kind of deal with, because you guys don't know how to do this yet by hand. You don't. And you will, you just don't know how to do it yet. So 340, 2 parentheses 4, rooftop to the x over 4, and then zoom 6 it so you can adjust your window the way you need to. We're going to have to look up to about 360. I'm probably just going to go straight to 400. So again, I went up to 400, hitting graph. Going to have to look right. Got to look this way. Take that X max out to 30. 20 probably would have done it. And there we go. Second trace 5. Get that little blinky do close, and you press enter 3 times, kids. 1, 2, 3. There you go. It takes roughly 4.8 hours. Sorry, 14.8 hours for the entire student body, except for those kids that sit by themselves at the lunchroom, to know your worst secret. That's kind of a mean joke there. I'm sorry if you actually do sit alone at the lunchroom. Make some friends.